Okay, so welcome back after the long weekend, and we're all excited about learning Java again, I hope. Again, I say learning again, because you've forgotten everything you know over the weekend. So what we're going to do today, I'm not going to do as much coding and programming today. Instead, what I'm going to do is go through a lot of theoretical PowerPoint stuff. Give you the concepts, because in the next couple of weeks, you're going to need the concepts in order to do a lot more of the coding. So when we start extending classes and we start using interfaces and stuff, it's better if I just give you the stuff now, and then we'll just do a lot more coding. So Monday will be a lot of coding. Today, if you have your computer, great, but you probably won't need it for anything. That would be applicable for both classes if you're in both of them. So I started this lecture last time, and I didn't get too far. I think I got to here, actually, slide number 2. Which is why I'm focusing today on the PowerPoint, so I can at least get through the theory. What are we looking at? The concept of inheritance, or extending classes. Inheritance allows you to create a new class from an existing class. We learned that last time. We build by extending. We use the keyword extends. So class A extends class B. And what does that allow us to do? It allows us to build functionality as we go through the hierarchy. So we start out with nothing, and we start adding stuff to it, start adding stuff to it, start adding stuff to it. So you almost have to think of the hierarchy in terms of, your game plan when you start creating these classes. Sometimes it makes sense to have a hierarchy, sometimes it's too much work. As an example, hello world, too much work, overkill. Even in the next example, probably too much work. Because here's the example here that I'm saying is probably too much work. If we have a person who's a student, you could just start out with a student, but then it would not make the example so easy, because then we'd start out with different types of students that came from that. But the concept being, we have a superclass and a subclass, and the superclass and the subclass has an is-a relationship, and one object is an instance of the other object, which is the is-a. So one object is another object. And this is where I stopped actually last time. So this is where I'll start. Or I stopped pretty close to here, I think. Anyway, it was like the second slide, and then I went directly into coding and then skipped the entire PowerPoint. So here's your PowerPoint. So let's see, the superclass in this particular example is super. So this is where I was saying, I kind of see it upside down. I always see super as being, I don't know, higher, but it's really lower. I think about it, it's a lower level of abstraction, because person is essentially an lower object in the hierarchy than student, but it's a super. So I was saying a super higher, but so the hierarchy's upside down for me. So it might be for you as well. However, just think, any super can also be a sub. What I mean by that, it's just whether or not one's below or above the other one in the hierarchy. And you can actually just draw this out sort of like an outline. Now if I were to do that, I'd put the person class up here, and then I'd put the student class underneath it. I go, well, what does that mean? Well, we get bigger and bigger as we go down lower, which is kind of weird. And if you think of the concept, the superest class of all is the object. Everybody's extended from object, and we don't have to put object on there. But in other languages like Objective-C, we extend from object, NS object actually. And we'll see that if you're taking that class, you'll see that it's more true. Actually, Objective-C is more true in terms of that concept. Because if we leave it out, is this particular example here, public class person, it's assumed that we're extending object, but we don't have to put it in there. Other languages, you have to put it in there, which is kind of weird. Otherwise, where are you extending from? It's like, well, object. And so here we use the keyword extends here to say that a student is a person. Extends, it's a superclass, it's a subclass of person. So as we build subclasses from one subclass to another subclass, we can take this subclass here, student, and we can make graduate student, extends student, and we can make another object. So if we did that, then student would be a superclass to the subclass of graduate student. We do that. The more subclasses we make, the more specific the object. The higher up the hierarchy to the super level, the more generic the object, all the way to the point where we're talking about it just a plain old object. Everything in the language is an object. So strings are objects, these guys are objects, all sorts of different things are objects. We have some things that aren't objects. Those would be like primitive data types and stuff like integer, floats, doubles, and stuff. And obviously this class structure concept, we don't really have any use for that outside of creating classes. But for the most part, everything else can be considered an object. Refresh your memory because I know it's been a week. We have data members and member functions that are associated with these objects, and here we have the data members up here. We have the public string name, and over here we have the integer, private integer student number. Do not repeat if you're using the keyword extends. Just think you automatically get all this stuff. So don't repeat over here. If you repeat over here, what are you doing? You're overwriting. So you're replacing this behavior with this stuff over here. Brand new people, they go ahead and they include all this stuff in here. What have they done? Why don't you just leave out the keyword extend? You've just pretty much created another superclass out of it because you're not really using inheritance in that case. However, there's a case in which it's okay to include something in here. And if you do that, and what I'm saying is include something that's over here, put it over here. And if you do that, you're overriding on purpose. You're overriding because you want to change the behavior. You want to change the data type. You want to do something with that particular data member or member function so that it can't, you can't call this one over here. You're going to call this one instead. And it depends on which object you're calling as to which method is going to run. As an example, let's talk about the methods for a second here. These are the constructors, and it's probably as far as I got last time. I'm not sure. But the constructor name here is student, public student, because it matches the class name student. So this one's called person. However, in here, we're still, every student is a person. So when we run the constructor for student, we run super. Super says, well, which constructor do you want to run? This one here, because we don't have anything in here, it's empty. Just a little bit bigger so you can see what I'm talking about. This is going to run the default constructor over here. You remember the constructor concept. Here's the default constructor. It doesn't have any parameters. And then over here, we've said under here, in the next constructor, where we have created a student, and we're taking on a name and a student ID, we're sending the student name using super back to this constructor over here that takes the name. So it just sets this dot name to equal initial name. Initial name's coming in from here. Biggest mistake a lot of people do is they can't figure out, or they forget to figure out, or they don't see the connection between the constructors, and they reinvent the wheel over here. And then when you do that, what you're doing is you're saying, okay, if I set a name in here, if I set the name inside a person, inside a student, I've redefined name. I've overridden the original name. The original name's over here. So I want to use what I brought in the inheritance. So my superclass, my subclass is taking in all the super, and I'm super, if you want to call it supering back, that's the terminology that I use for it. I super back to the constructors to initialize the data members that belong to this class. Because although we have this class here, the subclass, we have membership into two separate classes, which is kind of weird. We have a person and we have a student object. So when we create instances of these objects, we get a person and we also get a student. Two objects at once, essentially. And let me see if there's anything else in here. This is kind of a review from what I went over last time. In fact, now I'm remembering, I think I said I was going to show you the constructor order, and then actually I'd probably do that then. Probably will have a little bit of coding then, because I'll demonstrate the constructors too, which is kind of interesting to see, play around with some constructors. But here we have get student number, set student number, my setters and my getters for the methods for this particular class. Over here I get the get name, the set name, and I'm not repeating them. So the point taken is that we don't want to repeat anything. We can complement it. We can repeat it if we want to repeat it. We can supplement it. Yeah?
You can directly call the setGet method from the constructor also.
You can call the sets or the gets. You can actually I wouldn't do that though. I just call the constructors. So this is actually calling a constructor. This is calling a constructor. When we use the word super, we're calling the superclass constructor, and we're sending it information from the subclass. In terms of the methods, if I said, student, my student equals new student, I can go student.getName. I can call the method that belongs to person. that's part of student, because every student is also a person. So I get all this stuff as well as all this stuff, which means I don't have to repeat it. Would it be helpful to see it in an example? Or yeah? Okay, so this is where last time so I'm doing the same thing again over again, but I won't spend as much time doing the coding. Otherwise I never make it through the PowerPoint. But I want to do it anyway because I want to show you the constructor order. What I'll do is each one of the constructors, I'll have it print out something to the screen. I already have the code from last time. If you were here last time, we wrote this code together. I believe I haven't opened this computer up since I was here last Wednesday, so hopefully it's still in here. And maybe it was under Java programming, assignment number 2, perhaps. Let me close this guy. I'm not sure what ITU. Oh, that was a different example for a different thing I was working on. So let's close that one. Open up this one. So last time, oh, here we go. We had Dino, we had main, tetra, ultra tetra. Okay, so last time we were here, I was actually showing you an example of this. And what we had, oops, as soon as this loads and initializes, the base class was Dino. Dino was the dinosaur. This is the theme of assignment number 2, by the way. Dino had a name and he had an age associated with him. And name and age were here. Let me make this a little bit bigger so you see what I'm looking at. And this is the code we created last time. We had a get name and a set get. Ooh, a get name. I didn't have any sets. I just got the gets. I didn't have any. I had got gets, no sets, but it was only partially implemented. So you can fill in the rest of it. And then we created tetra. A tetra was a certain type of dinosaur, and a tetra here extended. And this is a subclass of the superclass Dino. So we use the keyword extends here to indicate that. And then he had private legs. So we have the name and the age in Dino. We have legs in tetra, because we're going to set a number of legs. It doesn't really make that much sense, but and here we have the default constructor. Here we'll say legs is equal to 0, and tetra's got super n. We have this one here where we're going to send n, which is the name, back to Dino, because there's no name in tetra. There was just legs. So Dino's got the name, so we were supering back for Dino, putting some spaces in here so it makes it easier to read. And this was, and we know that this here calls this default constructor for us automatically. Hopefully we got that part from a couple lectures ago. And what I'm going to do here, actually for Dino, in the default constructor for Dino, you can't really see the stuff being set, so I'll just do here is I'll just go here, system.out.println. This is how we get information to print to the screen, by the way, if I spell it correctly. It's an object, so it is capitalized. That's the thing I told you probably on day 1, I hope, that all objects are capital. So if you remember that, then I know that I made a typo there. So I'm going to say this is a Dino. So we know, and then I'm going to cut and paste this so I don't have to keep writing this over again. So copy, here we go. So the constructors for Dino creates Dinos. There we go. Oops, this has to be first, so I'll change the order here, actually. Let's just do this. Cut. That what you just noticed a few minutes ago was an error. If I do this, this actually has to go first, because when I say this, what I want to do is run another constructor. So I can't like run part of a constructor and then run another constructor and then go back and finish up the constructor. So by theory, this always appears as the first line in the constructor. In Eclipse, obviously, you saw an error message. Other programs aren't going to give you an error message. You're going to compile it, it's going to work just fine. And then you're going to go, how come the constructor doesn't fire? It's because, it's not the first line, and it didn't work right. So then what we did here is I also probably made tetra, and he probably was, ultra tetra was probably a variation of tetra. Oh, that's how far I got. So I created ultra tetra, and he extended tetra. So he was another tetra. And in here I can put in, I don't know, integer teeth. Give him some teeth. And this is what you're doing essentially for your dinosaurs. Each one of them is going to have something different that's associated with it. So pretty much I'm writing the assignment for you. And then I'm going to create a constructor for tetra. And I'm going to say, and remember, tetra doesn't take a the constructor does not take a data type. In fact, it has the same name as the class. So I'm going to go ultra tetra. Let's see. What are we going to do? Maybe let's just see what I did over here. In tetra over here. Oops. We got legs. Should refresh my memory here. Actually, let me zoom out so I can see this a little bit better myself. So we got legs we can set, and we can set name and age, I believe, but we don't want to do that. So legs. So I'm going to call this guy back for legs. So in my constructor for ultra tetra, I'm thinking, why do I have an error message on there? Probably because, let's see, return type for method is missing. Yeah, of course it is. No, let's see, super. Let's just call super here. And then we'll say teeth is equal to 0. 0 teeth on there. Why does tetra have a, I probably spelt it wrong. Somebody correct my error.
There's an R.
Tet.
On the top it's T-A. U-L-T-A.
U-L-T-A. Oh, there's an extra R. Okay. Thank you. That's what I need you guys for. All right, so what I'm doing here, I always make typos. My spelling's really bad. All right, typing's really bad, I should say. So what I've done here is I've called super, which is going to run my super up here. And actually in here I'm going to say system out, because the reason, actually maybe I should be able to paste this, right? Paste it. Ah, look at that. But this is a tetra. Ultra. Alta. You know what? Here we go. Ultra. I meant to say ultra. Ultra. There we go. Oh yes, of course. Actually, I can rely upon this automatically. There we go. Ultra tetra is what I meant to say originally. This is an ultra tetra. All right. So now, if I go back out in main, and if I create an ultra tetra, it should create a tetra and a dino. And then because this is the default constructor, let me just make sure I have something in here under tetra. Let me just put a system out in here as well. This is a tetra. Good. Good job on that one. Go back to dino. Dino's got a, this is a dino. So now theoretically, if I create a tetra, I don't have any other constructors around other than the default because I don't have anything in this class here. It's pretty empty. But if I go out in main, main's the program that's making all these instances of all these objects here. And don't actually need that. Take that comment out of there. Let's see. Let's take this guy out here because I don't want to have any system outs occurring. So I'm going to create one dinosaur, and the dinosaur I'm going to create is going to be an ultra tetra. Well, you know what? Let me leave this guy alone and comment him out. Because that guy is actually legitimate code. Let's just do this one. Ultra tetra, if I spelled that right. Sample. Equal new ultra tetra, if I spelled it correctly. Alright, so what I've made, I'm not going to do anything with it, but if I wanted to, I could say sample dot anything that is included in anything. Even though I don't have anything functional, I have nothing created in ultra tetra. I've got everything that was included from everybody before it. So I could say, you know, get name if I wanted to. Or how about get age? Get age. And sample.getAge would return the age that's automatically set, hopefully, if it's set. And it should be set because ultra tetra, the constructor for ultra tetra called super, which is a tetra. Where's my tetra? Here's my tetra. My tetra super, which is the default constructor because I didn't give super any parameters, I just said super. So This I know is going to be calling the default constructor of the superclass. That's what that means. I'm going kind of slow here, so it reiterates the point. Which means I'm going to set legs to 0 here. Ultra Tetra, did I set teeth to 0? Tetra's got legs to 0. And here I'm going to call super. So I'm making sure I can actually not get any errors. Super is going to set Dino, because Tetra is a Dino, comes from Dino. Super is going to call the Dino constructor. Here he is here. And he's going to set age to 21 in the name. So I should be able to now have all of this information set by default. For all of these default constructors should fire, which means I'm going to get, this is a Dino, this is a Tetra, this is an Ultra Tetra, printed to the screen, theoretically. Let's see if it works. Let's see. If not, I have a typo. Oops, let me go back up here and actually run the project. I'll probably have to save things in the process as well. Run as a Java application. And lo and behold, this is a Dino, this is a Tetra, this is an Ultra Tetra, whatever you call that thing. So, point being, we have automatic constructor firing that's going on. I have 3 objects that are created. And I can take the objects and I can transform them into their other object types if I want. So as an example, let me go back up here for a second. I only created, and I purposely commented out the rest of the code here. I created an Ultra Tetra, and I ran a method, but I didn't actually do anything. The method doesn't do anything. The method just gets the name. But I didn't print it out to the screen or anything like that. I could, if I wanted to, do something with it. But what I can also do is take this Ultra Tetra and say Dino, and then Dino is going to be what? My Dino. So Dino is the object name, Dino, which is the base, the smallest super object that we have. Dino, my Dino is going to be equal to Dino, and then I'm going to say sample. Whoops, if I spell sample correctly. So now what I've done is I've taken my sample, which is right here. Let me make this a little bit bigger so you can see it. And I've done what's called upcasting, because every Tetra, or excuse me, every Ultra Tetra is an Ultra Tetra, a Tetra, because we know by the thing down here. He's an Ultra Tetra, a Tetra, and a Dino. And we see that the constructors fired in reverse order. Actually, I forgot to note that. The first guy that was created was a Dino, and then we got in a Tetra, and then we got an Ultra Tetra, because we had supers in there. Supers went all the way back to the beginning. So it fires, we create the objects in reverse order. So now what I've done is I've taken, and why did I do this? Well, sometimes I want to treat apples like apples. Let's say I have an array of Dinos, and one of those Dinos is actually an Ultra Tetra. I can convert him, I can cast him back to a Dino. Now I have liked objects. I can keep all those objects in an array. Which is what you're going to need actually for the third programming assignment. You're going to have a bunch of people. Some of the people are teachers, some of the people are employees, some of the people are staff, but they're all people. They all get inherited from the same object. So you could take all those people, cast them into people, and this is what I mean by casting. And then you can treat them all like people because they're all the same object. Because arrays, as a particular example, only allows you to store one data type, and every item in the array has to be of the same data type. So the way you do that is you cast. And this is called upcasting because I've taken Dino, which is a super duper class, and I've gone from a sub all the way up the hierarchy to the super, which is why it's an upcast in terms of its data type. What does this do? It allows me to treat this sample here as a, this is going to be an interesting one here, a sample here as a, actually I created a new object here. I could actually take this sample and do a Dino on a sample, make him the same, but I don't want to do that because I don't want to get rid of sample. Instead I made a new object called my Dino. My Dino is a Dino version of sample. So now actually I only have a Dino, which is a single object here, and I have 3 objects up here because Ultra Tetra is 3, Dino, Tetra, and Ultra Tetra. Problem we get with this is if I take my Dino and I run something that's not in Dino but it's above Dino, I get an error message. It won't allow me to run it because Dino's not anymore. He's not an ultra tetra anymore. He got casted. So if I have something up here, let's say just pick something from the tetra category. Get legs actually is going to give me an error message. So if I say get legs up here, it should tell me something, and the error message it's going to tell me is it's going to change to get class. You know, that doesn't exist. Add a cast to my Dino. Well, we have to add a cast, and then we add a cast. We're going to change it into a tetra. So what we did was it took my Dino. My Dino actually includes it. This is kind of like taking an integer, turning it into a float, copying it to another float, and then taking the whole thing, turning it back into an integer or something. It's casting, which is not very safe to do, but if you know what you're doing, you can do it correctly. In this particular case, this actually was a tetra, so it actually has the information for it saved in the object, which meant it has a big object, it made it to a small object. Now I'm going to treat it like a big object again. And the object is the object. The object didn't go anywhere. We're just referencing it from its different states. So this would actually work, and I would actually cast it to a tetra. Not advisable though, because this is dangerous. What if this guy was never, what if Dino was never, my Dino was never a tetra, or never an ultra tetra? Would never have any of that information. None of that stuff would be around. So you're relying on information that may or may not exist, actually. This actually, you know, given garbage collection, it might actually not even work. This might actually give me an error. In fact, if I go system out, let's see number of legs, system.out.println. Let's just print it out, see what I get. Oops, I don't want to do. If I print it out, I might actually, well, do we set the number of legs? I didn't set the, well, and I set number of legs to 0 probably, so it should come out as 0. So otherwise I'm going to get a runtime error message that comes out, but let's see what happens. It probably is going to work, actually. Yep, 0, because the information was there. If I just created a Dino and did it, it's going to give me an error message. It's going to be unknown, undefined, or it's going to be blank because it's not set. I did set it because it used to be a Dino. I mean, it used to be a tetra, so even though it was an ultra tetra. So what we got here, and where I think I ended last time was, I'll just leave this here for you guys to dwell on, especially if you're watching the video. You can pause the video and type the code in. Last time I was running methods, and I was showing you how you can run a method from a method, and you made a good point. Can you call a method? I said, yeah, I can call a method. So let's say, for example, I don't have anything in my ultra tetra. He's the last class, the last dinosaur, highest one. And I can go as high as I want. I can go up to 25 different, or I don't know, 50 different, depending upon how much time I have to waste doing this, versions of dinosaurs. And then you guys get pretty bored, and you'll end up leaving. So what I'm going to do here is I'm going to create a method, and I'm going to call other methods inside of the method. But you know, I don't actually have to do that because I can just call the method. So for example here, let's say, I don't know, what do we got in here? Let me see, gets and sets, let's see. Ultra tetra doesn't have anything. What have I not created yet? So I got the get legs, set legs. I actually didn't set any legs, so I got get legs over here. I can call get legs. So in ultra tetra, I can say, you know, integer get teeth. That would belong here. And then this would return this dot teeth. So this dot legs is kind of an interesting phenomena, because then you have to change visibility. Well, okay, so if I did this dot legs, if I use this for something, let's say for example I wanted to use up here, I didn't do this, but it should be private. I've got private data members, so I'm never going to actually manipulate the data inside the methods. Instead, I'm going to use something that's public. And if you've done this, hopefully I did, yes, I did this. I just left off the private when I created ultra tetra. You should be making your data members private, which means you're always going to look at the methods anyway, because the methods are always going to be public. So Get legs is a better way of manipulating the legs if I wanted to change the legs. So as an example, in Ultra Tetra, I could say, actually I don't have a set legs. Let me create a set legs here because I want to set the legs differently. If I wanted to set the legs and I decided, well, I don't have anything to set the legs, I'm going to go back to Tetra and set the legs in Tetra because that's where my legs are defined. I could put set legs over in Ultra Tetra, but then when I went back to go look at it, I'd be like, where did that come from? And then I wouldn't have the behavior inside of Tetra where legs are defined. So as a general rule, what I'm trying to say is if you have a data member inside of a class, keep all the gets and the sets inside of that same class to manipulate that data member. That way you always know where they are. Because instead, say for example, I left out set legs. I just added it a few minutes ago here. Actually, let me make this void. Let me add it, actually finish it. This dot legs. Dot legs is equal to 10. Actually, you know what? We're going to do it this way. Equals n, and this takes on integer n. So set legs. There we go. And what I just did for those people who didn't see it was I created a new method called it set legs. It's void because it's not going to return anything, but it takes in something. It takes in n, which is going to be the number of legs, and this dot legs is equal to n. I'm using this in this particular case to demonstrate a point, although I didn't use legs up here. I could have put this in. Some people just like to put the this in there, and I've explained this before. But this means it's Tetra's legs. So if this wasn't private, if this was public, I could go super dot something, which you're never going to see. You're not going to see that because then you hardly ever see this unless you want to really point out that this is this. So sometimes you see this being used because people are using the super and they're playing around with it. But if you keep it all housed, if all the stuff about the legs is inside a Tetra, you'll never have to worry about it. You'll never get confused. So out here in Ultra Tetra, I could run this dot get, no, I was going to say set legs. Set legs to 5 as an example. I don't know, I'm just putting a number in there. And then it's going to say, well, what do you mean by this? Well, remove unreachable code. Whoops, I'm going to return. Hold on a second. Hold on 1 second. And what did I put this in get teeth? Hold on 1 second. Let me create a new method. Actually, let's just do this. Let me create a new method that says integer void set stuff. Useless concept here. Let's set stuff with n in here. And set stuff is going to be my hacked code, and my hacked code is going to say this dot what was it again? Set teeth. Set legs. Set legs is going to be equal to n. You're wondering, you're going this. What do you mean by this? And I'm using this out of context from what I just told you a few minutes ago because this is actually, this Ultra Tetra is a Tetra. So this actually works in this particular context. And what I'm saying is this is confusing. So for those people who love, not to confuse even further, but for those people who love the word this and use it for everything, it means absolutely nothing to me right now. Before, in the other context, it meant something to me because I'm like, oh, it's inside a Tetra. It's this. But this is not, this is an Ultra Tetra. So I can actually kind of leave it out if I wanted to. And you'll see that done more often, actually. You'll see it, just leave it out because it doesn't mean as much in terms of looking at it. What ends up happening is you find an instance in which you've got multiples. As an example, this Ultra Tetra in here has got a private legs, integer legs. And now we're going to have this situation where it says, well, keep side effect assignments, add suppress warnings of unused legs. Well, okay, that's because I didn't use it, but I could have a set legs in here. I could have a void set legs. let's see, legs is equal to n. Oops, and that's an integer n. And hold on a second. Public, yes, public. Public. There we go. And I should hopefully get a warning. Overrides tetra legs. Yes, I do. I get a warning here. And that warning says it overrides tetra dot set legs. Huh. So which one's going to happen? Well, because I've redefined it, I'm going to have this happen. However, if I use the this, and I made this up here private, excuse me, public instead of private, then I'm really going to confuse you to death because I'm going to have both of them because I can set the legs this one or I can set the legs for that one over there, and then I'm going to cause confusion. So long story short, overload, don't override, and don't use this unless you actually mean to like point something out. Like I'm using this one from tetra, not from ultra tetra or something, or I'm using ultra tetra's legs and not tetra's legs. And then you can figure out which object legs, when you have multiple legs going on, which object's legs you're talking about. Because what ends up happening, if you go back to my main example over here, I took this guy and I converted him from a dino, from an ultra tetra to a dino, and so now I'm going to have major confusion in terms of legs. If I have multiple versions of legs set for each one of them, it's going to use whatever object it is, and that's this. So this is Dino's objects for legs, if I were to use that in that context. So anyway, it's just a minor point. You'll never run across it. But what ends up happening is you see it all the time in code, and people always look at that and they go, what in the world is that? And it's because you got multiple versions of something, and I say, oh, I want this one. I want that one over there. It's like, yeah, just don't do that, and you never run into confusion. So in here, in this particular case, I got to get legs over here, but I already got to get legs, and the get legs is already in tetra. So, and this is tetras, but this is, you know, this is going to override. This is going to override another method. So, I can use this over here with this dot legs. What was I? I was actually over in ultra tetra. I'm sorry. This is where I overrode it because it's already in tetra, and I put it in ultra tetra. So maybe I should change the name so I don't confuse myself as much. So. Anyway, so I'm going to take this out because I don't want to do that. And I'm going to take this out because I don't really want to do that. Instead of doing this, I want to do this. And I want to call it something else, like set the legs or something. If I want to have, and this now I have two. I have set legs and I have set the legs. And I can call set legs, and this is going to call my set legs. This is going to call this one that I overrode, but it's going to call it from the right one. So out in main, get rid of that code. Set the legs, if I remember this correctly. Out in main. On ultra tetra, here I can say sample dot set the legs to 10. Oops, if I spelled it correctly and put the right syntax in here. And that'll set the legs to 10. And it's not going to call, it's not going to reduplicate anything, it's just going to reuse. So basically I was trying to point out that I was demonstrating, I was calling a method from the method, so which is what you asked about before. So have I totally confused everybody? No? Good, we'll continue. If you have, you're quiet, so. Yeah? Oh. That's like everything you ever wanted to know but didn't want to know about this in the objects. But you'll think about that further along the road and you go, oh, I remember she was talking about this. And I overwrote the method. Now I have two legs. Now I have two of this. Now I have two of that. So which one am I going to use? If you override, you can actually use this to go back to the previous legs that you overrode. So that's the wrong way of doing it, though, because you want to overload. And I haven't talked a lot about overriding, but not overloading. Overloading means you take what you already have and you complement it, you add to it. And we've been overloading the constructors. And this is an example of overloading. When we call super, we've created a new default constructor, and the new default constructor is overloaded. The original object is being called, that constructor is being called, this one's being called. And so we've complemented, which is what you want to do, complement the behavior. Because if you're going to override it, why bother subclassing? You know, you're just reinventing the wheel anyway. So let's move on. Class hierarchies. So every class is an extension or is an inherited class, whether or not it's declared to be. This is what I was saying before. Everybody comes from objects, and you'll see this funny little NS object thing. It means the same thing in Objective-C. Well, we haven't seen that yet. If a class does not declare, explicitly extends to other classes, it is explicitly extended from object. The reason why we don't see this by default is because we're not extending anything automatically. If we don't extend anything automatically, we come from object. Object is the default application type. So if we extended from applet, we would create an applet instead of a class that would be from the application. So in terms of Java, which is kind of funky, it's not the same as everything else. It's left out to say it's an application. So when we look at main classes and we start looking at the driver and we extend from applet, then we've changed the application into an applet automatically. We extended from a different object. When we do that, then we automatically created an applet instead of a program, which is great because then it saves us a ton of work. So in a lot of cases, you can take running programs and turn them into applets quite easily by, instead of leaving it blank at the beginning here, instead of just saying public class person, we can extends from applet, extends applet, and then all of a sudden, not object anymore. Leave it out, it's assumed to be object. Another point taken is if you leave out any of this, the data is automatically private, the methods are automatically public. So if you leave it out, and some people like to do that, you can actually leave out public on the class, and if you do that, the class will automatically be public. And this also brings up another point. So we have public, private, abstract. We have all sorts of different types of classes. We make public classes, and you'll see 99.9% of all the classes you make will be public. And we're talking about as the access method for the class. Because if this is private class person, this is not going to work. You can automatically probably see the pros and cons to that one. You know, well then I can't inherit. You can't inherit from a private class. Why do you want to use a private class when you know you're not going to? When you want to stop the inheritance, make the class private. You're like, well, okay, what do you mean by that? Well, okay, some classes like date, as an example, private class date has a day, month, year. I'm never going to extend from date. I want to keep date the same forever. Then I can use date inside of anything, and it's always going to be the same. And it's private. It can't be changed. It's my definition. That's one example. Because you can put a class instance of classes inside of classes. Actually, you know what? This merits another look. I know I was going to get past the slide today. I'm going to get past that slide. Inside the class, let's say ultra tetra. Inside ultra tetra, I'm going to say make babies. Point. Make babies. Going to make instances of objects, of dinos. I don't know why I'd want to do this, but so now this ultra tetra is containing, he's got 3 babies in here. He's got dino baby 1 equals new dino. Dino baby 2. Oops. I can call the constructors. I can do anything I want, actually. Baby 3. Anyway, you get the point. I'll just create 2 of them. So this ultra tetra can make babies. Can have 2 at a time here going on. And this can be used inside. However, the object here is that when we've created these, we can actually, if I do this, I can see what happens here. Yeah, let's do it this way. We have an ultra tetra, I think, already created. Ultra tetra, here he is. We want to see the constructors fire to see what happens, because we're going to have 2 extra dinos created, because each tetra, if I make the babies, ultra, so sample dot make babies. Make him babies. So when I create an ultra tetra, it's going to make 2 babies. Because I just ran the method here to make babies. We're going to make 2 dinos. And we're going to see the constructors for both dinos fire. However, the 2 dinos belong to, and they're enclosed inside a sample. So sample owns those two instances of the objects, which means out here I can't go baby one. Baby one, the scope is inside of that, so I can't go baby, what did I call it, baby one? Baby two. If I do that, I'm going to get an error message. I don't even bother typing it. Because, well, first of all, the instances aren't even made until this happens. And then once the instances are made, I have to control it through sample. So the code for those babies is going to be inside Ultra Baby. Ultra Tetra. Is going to have code in here to, I don't know what you're going to do with babies. Babies, okay, so maybe it's a date, maybe it's a time, maybe it's some functionality that's going to work, that you have an object inside of an object, essentially. So if I run this constructor, run this program that makes an instance of Tetra, here are my two babies that are created after the Ultra Tetra is created, because Ultra Tetra was created. Ultra Tetra is a Dino, a Tetra, and an Ultra Tetra. And then I have baby one, baby two. Maybe I probably should have said something in the constructors to differentiate. But I have two Dinos essentially created. But the two Dinos are owned by Ultra Tetra. They're inside Ultra Tetra. So in order to get at that, I'd go Ultra Tetra dot baby one dot, and I can get to the subclasses if I want to. As an example, let's just do this. What did I call them? Baby one and baby two. So I could go sample dot baby one. Actually, I don't think this is going to work. Dot get. No, I don't think it's visible out in me. It's not visible. It's not visible. All right, that's not going to work. I was actually kind of thinking about that for a second. The scope is inside of Ultra Tetra, so I'd have to use baby one and baby two inside of Ultra Tetra. He's not going to be visible elsewhere. So, and this should have been public. Actually, I should have put the word public in here. So, clean this up a little bit. We get the concept. Hopefully, objects inside of objects. Objects are owned by the different objects. Not the same as inheritance. We've nested objects inside of another object. We can still take this and inherit it again from another object if we want to. But we're going the hierarchy. If we do that, we're doing the hierarchy in the opposite order. Or we're doing the hierarchy as in terms of the order of which the hierarchy actually exists. So going back to the slide set, go back to that hierarchy picture. I am getting past this slide. If we had object, Dino, Tetra, Ultra Tetra, the babies are on this level. The babies are not in the hierarchy. So they're sub-objects. So there's no limitation on sub-objects. You can have as many sub-object types as you want inside of an object. Why do you want that? Well, let's say, for example, you have a checkbook program. And the checkbook program has debits and credits or something. And inside of each one of the objects that are representing the check, you might have multiple different pieces of information. It might be different accounts information, or it might be different stuff associated with that one object. And then sometimes it makes sense to create multiple different sub-objects to keep track of all that information, because then you can take the sub-object and use the same object-oriented techniques with it, instead of having to go back to, using data types and stuff like that. So it has limited usage. It's kind of like this. It's kind of one of those things where unless you know you're capable of doing it, you may not actually even try it. But when you do it, it's only good for certain things. You're going to run into it in assignment number 3. So assignment number 3, not only will you have an array of objects, and the array of objects you'll have to upcast. So keep that in mind if you're taking notes. You'll also have to create objects inside of objects, and here's how it works. So in assignment number 3, I can remember this actually, I don't even have to pull it up. You have teachers and students, and the teachers have students. So inside the teacher object, you can make students and have students belong to teachers. Or you could keep them outside of the object and put them in an array inside of the object. So you can actually have students and teachers exist in the hierarchy and access them within each one of the objects. So at any one moment in time, the teacher knows where the students are, and then the students might know which teachers they're assigned to as well. You can keep this stuff organized inside of objects or outside of objects. You have a lot of different choices with it. For the assignment, the easiest thing to do is keep it outside, actually. Create teachers, create students, and then create an array inside of teacher that keeps track of students, and an array inside of students that keeps track of teachers. I'm going to wait till Monday to go over that assignment though, because that's way far ahead. But just demonstrating a point, there is a time in which objects will have sub-objects. And let's say, for example, the date is a good example of that actually. And a lot of the built-in objects like string is an object. So whether you know it or not, if you're using a string class and you're creating a string object inside of an object, you're already nesting objects. So fields and methods and extended classes. So an object of an extended class contains two sets of variables and methods as we've seen so far, and this is basically the PowerPoint that's going along with what I've already shown you in the source code. Fields and methods are defined locally in the extended class. Those are those legs, teeth, name, age, and they're inherited from the superclass. What are fields for a student object in the previous example? For a student, what are the fields associated with a student object? It's everything. That's the quick cheat sheet answer, just say everything. Well, you have two actually. You have this one here from person, you have name, and then you also have student number. So you have two fields. And you're wondering, well, how come? Student really only has student number, but it's extending person, so it gets that too. So the point being, you get everything from the inherited subclass, from the superclass, so everything is included. Constructors in the extended classes we've seen so far, and this is the syntax for it. Well, we've actually seen this. The constructor of the extended class can invoke one of the superclass's constructors by using the super method. We don't have to do the defaults, as I've shown you. We can actually do other ones. And we pass the information from the same command line, comes into one constructor, and it automatically goes to the other constructor. And we see that actually in this one here too. Oops, it's in here, where we have, this is a constructor here, student, and it's taking on a student name, and it's also, this should be all in one line, but it's taking on a student number as well. But we're sending the name over to here, so this one is actually going for this constructor here, setting this dot name to initial name. So although, and this is the biggest question most people have when they start coding is like, how do you send the information to the constructors? Well, you have to take it all in from the constructor. So this constructor here has to be built to take on the two parameters. Although it doesn't actually own one of the parameters, the other parameters over here, the names over here, it only knows about the student ID. So although it's assuming that it's going to pass it back, so it runs super and it sends the name back to person. And then it sets student number to this ID number, whatever it was sent in, the student ID, when the student was created. Let's see. Yeah, in my examples I was running the default constructors, but you don't really have to. You can run any of them. So if no super constructor is invoked explicitly, then the super constructor's default constructor will be invoked. So in a lot of cases, in my particular example that I put together, you can actually leave the super out. Although you'd be not worth the teaching experience because you wouldn't know what super meant, but if you left it off, the default constructor is going to go automatically. Not the case with this inside of a class. So if you're calling a constructor that's not the default, and you put this as the first line of whatever constructor you're calling, that will explicitly call the default constructor of that class. If you leave out this, no default constructor fires. So by default, only one constructor fires per instance of each object that gets created. So if you don't specify, you've created, in fact, here, actually, let's just do this. I'm going to take out the thises. Actually, I'm going to take out the supers. That's what I'm going to do. So I'm going to go over here, and I'm going to comment this out. This is the super for ultra tetra, and I'm going to take tetra's super out, considering that I'm going to be calling the default constructor. And I don't have a constructor in Dino and ultra. There we go. So if I remove these supers, the super should run automatically. I'm going to get those constructors fire. So automatically. However, it only works with the defaults, which means if I wanted one of the other ones to run, it's not going to run. So same results. I commented out the supers, but I got the same results. So, long story short, you know, you can pull it out. It's good practice to put them in because then you know you intended the super to run. Otherwise, if you're running one of the other, I don't have any other constructors here, but if I had another constructor I wanted to run, I would put the super in, give it the parameter that's going back to the previous instance that was created, and then it would run automatically. So by default, even if you don't specify in the current class anything, you're going to get the default constructor, which is why it's considered the default constructor. So constructors are not methods, they're not inherited. So what does that mean? Well, you don't inherit constructors, you can just call them. By default, the default constructor is going to run for each instance unless you specify another one. But there's no inheritance with constructors. So it's invoked automatically. Because constructors aren't methods, actually. And although they look like methods, they act like methods, but they're not methods. They're treated differently. There's 3 phases of the object construction. You've seen this slide, but here's the textbook information. When an object is created, memory is allocated for all of its fields, which are initially set by their default values in the constructors. Then it follows with a 3-phase construction technique. So it invokes the superclasses constructors. Remember, dinos were created first. So the superclass constructors fire first. We'll get a dino first. Then initializes the fields and everything else, and then executes the bodies of the constructors for each one of the subclasses. So we got a dino, a tetra, and a super tetra, whatever it was, ultra tetra. Yeah. That was created, and then the babies were created after that. So we had all of the objects that were created from a descending order, from starting with the super all the way down. So invoke superclass constructors executed using the same 3-phase construction. All objects are created using the same 3-phase construction. The phases are the constructor first, the initialization of the fields, and the blocks second. Initialization blocks, if you remember, were not inside of constructors. They were just blocks of code that were put into the class. And hopefully you remember, for those of you who were here for that lecture, when I was talking about initially introducing constructors, I said you could put an initialization block in there. I said, you don't want to do that. I said, well, most of you looked at me and went, I don't know why. It doesn't make any sense. But now it's supposed to make sense because you get the constructor behavior with inheritance. You don't get initialization blocks. You don't get to choose. They're going to go anyway. With inheritance, we can select which constructor we want. With initialization blocks, they're automatically going to fire whether or not we've inherited or not. We can't turn them off. They're on there automatically, which makes no sense unless you want it to happen all the time. So if that object must have this initialization, must occur, then take it out of the constructors, put into a separate block, and then you're guaranteed it's going to happen all the time. But usually you want to pick what's going to happen. So it gives you more flexibility to put into constructors, and then executing the body of the constructor of the class that called it is the last part that occurs. So here's your illustration to look at the construction order. This is class X with class Y that extends class X. And this is like the worst example in the world. And really sadistic teachers give you this on exams. They give you a bunch of constructors and they tell you, and they give you a bunch of, and they say, what's the output? And you gotta go trace through all the different instances of all those objects to see, well, which one created this, which one, which is a pain in the butt to try to do. So this slide sort of mimics it, kind of. Maybe not. So it feels basically going through and illustrating the order in which the constructors are fired. So inside here we have one where we've got a which OR is going to be equal to an XOR, and so we can see the output that occurs. If you want to go ahead and follow it through, perfectly fine. Otherwise, take a look at the example I just showed you a few minutes ago with the dinos. That's a better, simple kind of thing that shows you the constructor and orders. Overloading and overriding methods, as I mentioned before. Overloading is good. Overwriting you do in minimally to get the proper effect that you're looking at. And in most cases you should be overloading. Overloading provides more than one method with the same name with different parameter lists. Overloading creates polymorphism. Because we say print, One says print integer, one says print double, one says print something else. And what we've done is we've got multiple print methods. We can call the same print on an object and say dino.print and put an integer in there. Dino.print, put a string in there. And the method itself picks which one matches, when the method invokes, the method that matches the parameter list actually invokes, which is polymorphic, because we've got, it's an example of polymorphism in the behavior in the language, because on the fly during runtime, we've transformed Dino to print out anything it wants to print out. So we can, regardless of what we send it. That's how, and if you're familiar with C and C out, that's how C out and C in works actually. Actually, it's how system in and system out works in Java as well, where we system out integer, system out float, system out string. It all gets converted to string actually, but allows for it. So by definition, overloading an inherited method means simply adding new methods with the same name and different signature. Okay, so I can actually just show you this because I showed you overwriting. When you use the same parameter, let's just use a, what was it before, get legs? Here we go, let's just modify this one here. If I say set legs, I have overrides tetra settings because we've got set legs here that takes on a parameter. If I change the parameter sets and I say integer x, now I have a method that overloads it. So if I can run set legs with 1, or I can run set legs with 2 parameters. And why do I want to do that? Well, I don't know why I want to do that, seriously. Up here I can just say, private integer back legs. And we'll have a 4-legged creature now. We have back legs and front legs. And maybe over here we've got the tetras up here. The tetras, this shouldn't change this one, the front legs. Front legs up here. I know it's going to give me an error message. Say front legs. Get front legs. So a tetra only has front legs, but an ultra tetra has front and back legs. So I put the front legs in, oops, I'll change it everywhere. I've just modified tetra here. What did I do here? Oops, I left out the R over here. There we go. I modified the nature of our animal so that tetra has front legs, and now ultra tetra is going to have back legs, and we have a new one called set legs. So if we set the legs of an ultra tetra, we can actually set front legs only. If we run the method that, and I'll just do it in a few minutes, where this one's going to go set front legs. Oops, do we have front legs in here? What was it? Hold on, I have to see what I called it now. Front set legs is just called set legs. All right. Oops, ultra tetra. Here we go. Wait a minute. Here it is. This is what I mean by the multiple tabs here. Set legs, it only takes on one parameter. It knows that it's going to be the previous one because it only has one integer in it. And then this one's going to be, this is where I would use this actually. Back legs is equal to x. And back legs is not capitalized. That's a good example for why I would use this. Because when I look at that, oh, this. That tells me front legs and back legs are not all in the same class. I'm talking about this back legs. That's a good example of what I was basically trying to explain. So if I go out here over in main, I can set, he's going to make some babies, but I'm going to go sample dot set legs. And now you see I have both of them here. I can set legs to 5. Where I'm going to set, from a tetra point of view, I'm going to set only the front legs. Well, that doesn't make any sense, the number, but anyway, hopefully you get the point. Or set legs to 5 and 5. That's overloading. So I have 2 set legs, for those of you who can't see it from the back. This is an example of overloading a method where in the inherited class of the ultra tetra, there's two set legs. One of them that just sets the front, and one of them that sets both the fronts and the backs. In this particular sense, it makes absolutely no reason why I would want to set a number 5, but you know, imagine I'm just setting something. And here, I can run both, and it looks like the same method call, but I'm setting a different number of parameters. So if I actually, you know, you can see something happen out here, where we can go set legs. I can say system out. Let's see, front legs set. This is why I hate typing. Front leg set, this is going to be in the tetra, and then in the ultra tetra, I'm going to say system, I should have just cut and pasted it, dot print line, back and front set. So if I run it, both methods exist. One sets the front legs, back and front set. That's because I called front from the I called the front and the back from the same one. So one method just used one of them. The other method used both of them. So. Oops. There we go. So that is overloading. Overriding is when you use the same footprint, same number of parameters, same method name. You put it into an inherited class, it automatically overloads, automatically overwrites any existing method that might be in the same object, so from the previous class. So overriding replaces the subclasses implementation. You can still get at it though. If you upcast the object back to its other object, it doesn't know about the inherited object. So if you change the object form, you can still get at the overridden behavior. It doesn't replace it 100%, but in purposes of the inherited object, it does. So overriding replaces superclass implemented method. Both the parameter list and the return type must be exactly the same number of parameters, same return type as well. So I could have void set legs, integer set legs, string set legs with the same number of parameters, and it would be overloaded, not overridden, actually, because it's a different return type. If an overloaded method is invoked on an object of the superclass, then it's superclass's version of the method that gets implemented. So it's the highest one, the latest and greatest method implementation that actually gets invoked. An overridden method can have different access specifiers from its superclass's version. But only wider accessibility is allowed. If it's private, you can make it public. But if it's public, you can't make it private if you're going to overload it. So it's a wider, you can change the access modifier, but you can widen it. And also overloading it, method throws cause, well, we haven't looked at throws yet, in exception handling. Causes can, the clause can have fewer types listed for the superclass. Don't worry about the throws at this point because we're going to have a whole entire lecture on exception handling for throws, which we haven't seen yet. So accessibility in overriding a method can be overridden only if it's accessible in the subclass. If it's private in the subclass, it's not visible in the superclass. So going back to that example, if I have private methods aren't visible through inheritance. So right now I've been taking all of my data members and making them private, and all my member functions and making them public and saying, well, that's the standard, that's what you should do. If you don't want it overridden, make it private, and then it makes it accessible, but only from that method, only from that object. Private methods never get inherited, they're not visible, so you don't have to worry about it. But again, you're defeating the purpose of inheritance. If you make everything private in the class, nothing gets inherited. So only public methods get inherited. It's just the same way as private data is kept private. So private methods in a subclass can't be overridden, obviously, because they're not visible. And if a subclass contains a method which has the same signature as one in the superclass, these methods are totally unrelated. So we can do this with private data too. If we have a private data legs in tetra, and we do private data legs in ultra tetra, they're two different legs because they're not inherited. So if the easiest way to remember is remember that private's never inherited, so we don't have to worry about it. It's always hidden from inheritance. Package methods in a subclass. So it can be overridden in a subclass in the same package as the superclass. Package rules are the same, actually. So if you included a package in the sub and it's public, it's also public in the super. Excuse me, if you included it in the super, it's also public in the sub. So every subclass includes everything that's public from the previous class that you're inheriting from. And we have protected. Protected public methods always will be protected and public. Not as simple as it seems. That is a typo. So protected is interesting. Protected makes it inheritable. So it's public to inherited classes, but it's private to main, to outside classes that are not inherited. So unfortunately, what ends up happening is you run into a case in which everyone just starts putting public on everything. And then you realize, oh, it works. But then again, you've left everything, the integrity of the class is totally open. It's like, not having to worry about what lock to set by not locking any doors. Just leave all the doors open, and then you don't have to worry about remembering your key. So it's kind of like the same logic. You don't necessarily do that because then your entire hierarchy is going to fall down because you can change anything you want. So it's better to deal with the issues when they come up and go, well, how come I don't have access to this? Because I didn't make a public method to get to it, or that method is private in the base class and it needs to be public, and then you start changing things around. Here's an example where we have sample classes. Here we have, this is another convoluted example actually, where we have public class, so we have package P1 and we have package P2. They're public because we don't have any access method associated with it. And then we have public base class base. And then in here we have concrete that extends base. We have private void pack, print, protected, public, and then we have a public final void show. And then down here we're going to have public. Doesn't really matter because this is the extended class. What's going to basically give us issues is this private up here. And then the output, well, might get some error messages if we try to run if we try to run methods from an inherited public, even if it's public, an inherited class that has private methods from a base class, we're going to have problems running the private method, long story short, because it's private. It should be protected, essentially, and then you're not going to have a problem. So I don't like that example, so I'm going to kind of skip through it. I'll show you another one on Monday that's actually a little bit clearer. It's like that, guess the constructor order game. It's not a good example. Hiding fields. So fields cannot be overridden. They can only be hidden. How do you hide it? Make it private. Well, it is private. So if a field is declared in a subclass and it has the same name as the one in the superclass, then the field belongs to the superclass, can't be accessed directly from its name anymore. So when there's no way of overwriting overwriting fields. Fields are the data members or data variables that you have in there. Legs, name, student ID. All you do is redefine them, and then you've automatically replaced them, and you've hidden the earlier version of it, which is what that is basically saying. There's no overloading data. There's only replacing it. Which is why if you take an inherited class from a class and then you go ahead and say, well, student is inherited from person, and you go ahead and redefine name, well, you've hidden the original name. It's still there, but it's hidden in the person object. And as I was saying, if you upcast that person back to a student, then it's not hidden anymore. But, it's not good practice to hide stuff unless there's a purpose for it. And there might be a purpose for it. Who knows? Here's our polymorphism, as I mentioned before. So an object of a given class can have multiple forms. There's many different forms of polymorphism. I've actually given you two. I've only explained one so far. For an object to react to different method calls in different ways is a form. For an object to be upcasted, when I took that tetra and morphed him into a dino, that's polymorphism as well. So the objects changing states, becoming different types of objects, all within the same hierarchy, is polymorphism. That's actually, there's more than these two examples too, but these are the two I've given you so far. And the other one is when an object can react a certain way to a method call, depending upon what it was given. That's a polymorphic behavior as well. So an object of a given class can have multiple forms, either as declared class types or as subclasses of it. So that's, person morphing into a student. An object of an extended class can be used wherever the original class is used. And that's by casting it. So you take a person and change them into a student. Well, take a student, change them into a person. So you can only go wider. So question, given the fact that an object's actual class type may be different from its declared type, then when a method accesses an object members which gets redefined in a subclass, then which member of the method refers to the subclasses or superclasses? Well, here's the answer actually, and you can probably read it better than I can read it too. Make it a little bit bigger so you can see it. So when you invoke the method through the object reference, the actual class of the object decides which implementation to use. You get that with polymorphism when you start doing upclasses and you have data that's hidden. Then you know it's either data members or member functions that are hidden, and then you cast the object. You turn the student into a person, or the tetra into a dino. Then it decides on the fly which object type you are as to which method and which data it's actually going to use, which is kind of weird. And that's polymorphism because you're morphing. It's almost like if I were standing in front of you and I said, well, I'm your teacher. Okay, great. And that class is over with and I go to a bar and I have a beer with you. And now I'm your friend. It's like, wow, how did that work out? Well, because I transformed. The object person's transformed from a teacher to a buddy or something, but I'm the same person. So you can take your objects and you can transform them all over the place and put them in different scenarios and situations. And they'll act differently. I'm not going to lecture to you in a bar. Hopefully. Although I have been known to do that. I'm not going to do that. Instead, I'm probably going to enjoy a beer with you or something. But when I'm here, I'm certainly not going to show up with a beer in my hand. Instead, I'm going to have a PowerPoint in front of me. But it's what the objects are doing. And they have accessibility. Unfortunately for me, if I see you out and about, I still know you're one of my students. I don't know if these objects have the ability to forget. But I think you understand the point. So when you access a field, the declared type of the reference decides which implementation it's going to use. So think of it as a situational thing. If the object is out and about, the object is a friend. If the object is in the class, the object's a teacher. So, example classes here we have Super Show. Am I doing on time? I'm doing good. That's good. I don't like these examples in here. I'll show you some better ones. This is essentially showing you different object types, running different methods, the same method. We have up here, we have Super Show. Super Show has a show method. And then we have Extended Show, which extends Super Show. And this one has a show method. Two methods with the same name and tied to two different objects. One of them is a subclass, the other one's a superclass. We make a couple of instances. We have an extended show here. Extended show is equal to a new extended show. Super show, super z equal to an extended show. This is what I did with the dino actually. I took and created a tetra, called it sample, created a dino, made it into a tetradino because I took and casted it to dino. But this is slightly different because it's taking and having it equal to this object instead of creating a new object, which I didn't want to destroy the first object. So I'm creating an extended object, I'm creating a super object, I'm creating the base, I'm creating the the sub, creating the base, creating the sub. I have two show methods, one's part of the base, the other one's part of the subclass. And I'm running both of them, and the methods are going to invoke on different object references. So if I'm a Super, I'm going to get a different show than if I'm in extended. And the behavior is going to be different because two different types of objects. So if I create two get legs, and I put one inside, I don't have to do this, probably guess what's going to happen. Put one inside a tetra and the other one inside of ultra tetra, and I run get legs on both. Well, the tetra get legs is going to run for the tetra object, and the get legs for the ultra tetra is going to run for the ultra tetra object. So it depends on the method that's associated with the object type that I'm running as to which method is going to actually be invoked. And I can take one object, turn him into another object, and he's now the other object, so I can run that method. Polymorphism. Just if you remember that part, the polymorphic part, then you've made some progress. Java is strongly typed language. It is. So is C++ actually. Let's see. Strongly typed. What does that mean? Everything has a type. So as I was mentioning before in your third programming assignment for this course, after you get done writing dinos and stuff, it might be the third. I don't know. It might be the fourth. One of them, I know I left it in there, was creating teachers and students, and you'll have to put them all in the same array together. It's like, well, they're all people. So if you could take a room full of students and put them all in the same array with the teachers, and you have to make them compatible, and you make them compatible, you cast them. You upcast them into the same object types, and then you have created an array of a particular object type, and then you load it up with instances of those things that you've made. And that's what you're doing essentially for compatibility reasons. The only reason why you're doing that is because Java is a strongly typed language. You can't mix apples and oranges, you can only have apples and apples together. So in terms of compatibility, when you assign a value of an expression to a variable, the type of the expression must be compatible with the declared type of the variable. So if it's an integer, it has to be assigned to an integer. So it must be the same type or subclass. So in order to exchange objects all over the place, actually, you can take an array of anything you want, as long as you treat all those things like objects. And you'll see it all the time. It's like object space, my objects. My objects can be anything, because we're all everything in Java is an object. It's all inherited from object. So if you treat them as object, in fact, sometimes you see object used as a parameter. Then you have instant polymorphism, because all you do is send it an object. Any object works as a parameter for that particular function or method. Null object reference is compatible with all reference types. So you can check for null. It's either an object or it's not an object. Null says it's not an object. So if we're not an object, any object can tell whether it's an object or not. So the types higher up the type hierarchy are said to be wider. Let me explain that a little bit. So higher up the hierarchy, what does that mean? Well, it's actually more specific. So a tetra is wider than a dino. He's higher up the hierarchy. Or less specific than the types lower down the hierarchy. Excuse me, I just said that backwards. Dino is higher because he's higher up the hierarchy. If you go down lower, I always get this upside down. For some strange reason, I think of it upside down. It's backwards. I've never gotten over that. Let me just read the slide. So hierarchies are said to be wider or less specific than the types lower down the hierarchy. Simply, lower types are said to be narrower or more specific. So it's the exact opposite of what I think in terms. Tetra is narrow, dino is wide. Because we're all dinos. Not all of us are tetras, though. So actually, I just came up with a good way of remembering that. Whatever you can, if we can all get reduced down to one type, that's going to be the wider type. So if we can all, if I made like thousands of dinosaurs, all of different types, and I can make them all into dinos, dino's the wider type. If they're all narrowed down to dinos, then dino's the wider type because I have a wider variation that I can create. I can assign my dinos, all of my different types of dinosaurs all down to the same type. If only 1% of them are ultra tetras, that's a narrow type. Because they can't all be ultra tetras because some of them never made it past tetras, or some of them never made it past dino. So, and this is only in terms of type conversion. So being able to, if I were to make an array of dinosaurs, which type would I pick? Dino. Yeah, because they're all dinos. That's the wider type. If I made an array of tetras, half of, and I'm only going one angle, I could have dino, then I had tetra, then I had super tetra. Well, I can have dino and I can have hectra and then super hectra. Or, I can have all these different types that are associated with dinos, and they all come from dino. So if I'm going to make an array of dinosaurs, they're all going to be dino. Because all those dinosaurs can be converted to dinos. So it makes it a wider type. Widening conversion, assigning a subtype to a supertype. Yep, can be checked at compile time, no action needed. Actually, the Eclipse will. Oh, good question. I don't want to do it right now, but Eclipse might actually give you an error message if you try to adjust upcast the type and it's the wrong type for the object. May or may not do it actually. At compile time it will. Narrowing conversion, convert a reference of a supertype into a reference of a subtype. You narrow it from a super to a sub. So it's the exact opposite, because if it's a supertype for the student and the person, the supertype is the person. To make him into a student, I always think that that's a sub, which it is a sub, but it makes it narrow. Although it makes it bigger to me. So I don't know, I always think of it opposite. Must be explicitly converted using a cast operator. And we saw the cast operator. We put the name of the object inside of opening and closing brackets. I called it an upcast. We'll see that again, so don't worry if you missed it initially. So the types higher up the type hierarchy are said to be wider. This is the same slide, wait a minute. Well, two kinds of type conversions here. Widening conversions, assigning a subtype to a supertype. I believe that this top part's the same as the previous slide. Narrowing conversion converts a reference of the supertype into a reference of the subtype. Just take it for granted at this point. And then here we go. Here's some examples to put it in perspective. Explicit typecasting, so we have a type name with parentheses before the expression. This is what I did before, but this is actually taking and creating an object. We can do this with anything. Everything is an object. So if we wanted to create we have all these variables, and they're all of different object types. And we all want to put them in an array. We take all those objects and stuff them in an array by making an array of objects. So here we have object 1. This could be Dino object 1, and we put Dino in here, and we're taking the string here. So string is an object. So we're taking this one and putting it into it. The only problem with object is there's no functionality with that. So eventually you're going to convert it away and we're going to put it back into what it was before. What are you going to do with an object? Can't really do very much to it. If I took Dino and turned him into an object, he'd miss his legs and his name and everything else and his age. There would be nothing associated with him. It's just an object. But I can compare him with a string and see if he's the same. And it would come out and say, nope. But I could still do the comparison, which is why we're doing this. Or I could still hold them in an array. So this is widening, or making them all into objects. For narrowing, it must be provided, and it's unsafe cast. Well, that's what I was saying before. If we don't know that tetra was a tetra, and we have a dino, and we try to take the dino and turn him into a tetra, we have to remember that he used to be a tetra. Otherwise, we're going to we're going to downcast him, narrow him down into a type that he may not necessarily belong to. And usually you get an error message. You may not actually get an error message, but you're going to get some really weird functioning. So what I'm saying is if I took a tetra, upcast him to a dino, I widened him, made him into a dino. If I take the dino and cast him to a tetra again, I've narrowed him back to a tetra. But what if he was never a tetra before? Then that's why it's unsafe. Because what if I have a ultra tetra? Well, an ultra tetra is a tetra, so I'd have to start out with an ultra tetra, cast him to a dino, take another tetra, cast him to a dino, take those two dinos and cast them to ultra tetras. Only one of them really was an ultra tetra. The other guy was never an ultra tetra, so he's not going to get cast correctly. So it's kind of unsafe to go back and forth. So normally you do it for particular purposes like comparisons and stuff like that. So. And here's an example here. We take the string and, we're going to turn it into a double. It was never a double. It was a string. So kind of unpredictable as to what's going to happen with that string. So if the compiler can tell the narrowing cast is incorrect, then it's going to have compiler, otherwise you're not going to see anything at all. So if the compiler can't tell, the runtime system will check. And when your program's running, you'll get some interesting behavior that occurs. So class cast exception error is probably going to be thrown. And here's an example of some wrong typing. What is this? This is an array. For those people who have never seen an array before, this is what I was talking about. And we have public class type test. This is an opening and closing bracket. We're calling the array P. The only difference between an array, for people who are brand new to programming, and regular old variables is this holds many of them. In fact, it holds 10 instead of just 1. So the syntax is actually the same. If we took out the brackets, it would be person space P is equal to new person, semicolon. That would be one person. So if we say person, we put this array symbol here, essentially. We call it P is equal to 10. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because the numbering starts with 0 for the index values for people who are brand new to programming. And in here, what are we doing? We're saying we have new person and we have new student. And this is from our previous example. And what we've done here is we've taken this person P array, we're putting some students and people in them. So we're mixing and matching actually in the same array. So for I is equal to 0, I is less than 10, I plus plus is a standard for loop for those few people who are brand new. If I is less than 5, well, we're only going to do 5 essentially. We're putting 5 students in here, and then we're putting 5 people. So PI is our number from 0 to 10. The first 5 are students, the next 5 are people or persons. Out here in main, because this is, whoops, what happened? Hello. That was interesting. Out here in main, because this is our class type test. Oh, excuse me, we put main inside. We didn't create a separate driver. We put the main inside. The main method is inside of type test. All one program, really bad practice. In our main program, we have person 0, 1, and we're typecasting. This one here, the first element to a person. Now he was a student, so a person comes before a student, so a student is a person. That works just fine. And this one's going to work just fine as well. For a student, this one's going to work. Excuse me, this one's not going to work because number 03, so let me make this go down here a little bit. We're going to get these error messages that are on the side here. So on the first error message we're going to get here is we're going to say, found a person required a student. So we created it, we put in, and what we're doing is essentially have incompatible types because we put half students and half people in there. We can't treat them all the same. So the ones that are students don't include persons, but the persons include the students. So half of the array works, the other half doesn't work in terms of the compatibility check. And it's just a demonstration. Don't worry if you don't get it, it's just kind of a stupid example. It's just a demonstration showing you how you can stick all this stuff in the array, it's going to work, but what's going to end up happening is you're going to start doing checks on the items to work with them, and you got a person instead of a student, or vice versa, depending upon which item in the array you actually picked out. So what you're going to want to do is basically convert them all to the same thing. But then you have an issue with, well, if you converted them all to the same thing, and you get them all out of the array and you put them back, how do you know what they are? So if you have 50% of you were of one type and 50% of the other type, and I put you all together in one room and I mixed you up and I put the same label on everybody, how are you going to know which one's which? So it gets confusing, long story short. Bad example, but it gets, I mean, not a bad example, it's actually kind of a good example, but last but not least, and I'll end with this concept actually, I'll end this class with this concept. Type conversions here. We can also do a test. So remember I said is a instance, so we can say a student is a person. We can test to see if we have an instance of, which is how we're going to solve that problem. Because if we make you all into the same, put you in an array and pull you all out and try to get you out, we have to test who you are first. Otherwise we don't know. And this is it's the solution to the problem of the confusion is the object, and we actually use in this particular case an object type. So if we took this example is coming off of the string that got turned into an object. If it's an instance of string, and this is the syntax for it, so you're taking the object, you're testing the object to see if it's an instance of string, if it's an instance of person, it's an instance of student, then turn him back into a student, turn him back into a person, turn him back into a string, whatever he happens to be. And here we had the conversion from string to object, and the object we're testing is called obj, it's just the object from the previous example. So string2 is equal to string object. Because it came out true, we could have an else here and say, well, if it's a person, okay, no, is it an instance? We can use this, can be anything. It's any object type that we want to compare it with to see if it's an instance of something. So. All right, let's stop at this point, actually, because if this is new material, it's kind of overkill for some. So Monday, we will probably finish Dinos and get on to interfaces and abstract classes, moving right along. You've gotten most of the information in this particular lecture. It only has, I believe we only have like 5 slides maybe left, but it gets into a concept I don't want to rush through. So we'll pick this back up on Monday. So you should be working on assignment number 2. You can probably finish assignment number 2 already and be on number 3, probably. Next week we'll be working on number 3.